argument. So actually this is again related to logic, what we have already done, but it is not exactly the same proposition logic, a little extra thing. Okay, so there will be two sides. Okay, there will be some sentences or propositions like that, and it is on the left side, and there is one word, and this is fixed. It is called therefore. Therefore, so after therefore, you will have a conclusion. So therefore is in middle, and then there will be some sentences. Normally it is not many, normally it is only one or two. So we call the whole thing, this whole thing is the argument. This whole thing is like a paragraph. So in paragraph, there are some sentences here before therefore, and then say 3, 4, 5 sentences, and then therefore, then you have one or two sentences. So whole together is the paragraph, and this is called argument. So it is the structure, and the left side thing is called premises, or premises premises MI. Okay, and the right side thing is called conclusion. Premises word I used earlier. Sometimes the premises also called conditions. Okay, you can also call conditions. So there will be some conditions, normally more than one, 2, 4, 3, 4, 3, 5, 7, like that. And then there is one fixed word, therefore, and one sentence or two sentences. So that will be the conclusion. So let me write one thing like, okay, so today is Monday. We go to the uh, shopping mall on Monday or Friday. Okay, when we go to the mall, we eat pizza. Okay, after we eat go back to home with pasta. Okay, so today we are at home with pasta. Therefore, it is a Monday today. So what do you think? This is the example argument just I have made now. Okay, so it is one example, and if you read the thing, then you will understand that there are some facts in the premises, there are some conditions given in the premises, and therefore is one word, and after this word there is a conclusion. So all the sentences before therefore are the part of the premises, and the part after therefore, that is the conclusion. So now the whole thing is, whole paragraph is an argument. Now you will check whether this argument is valid argument or not. So check the argument is valid or not. So this is one thing we need to do. But for doing that, we need to recall again one word, that is tautology and fallacy. So in between there are three things. So we call this argument can be valid, not valid, and invalid. So you can just think about three states of argument. So valid argument will be when it is tautology. Okay, so this is one thing. So okay, let me write tautology. And another thing is invalid. So that will be called, okay, it is invalid because or you can write like this: tautology will make this argument valid, and fallacy will make this argument invalid. And what I am saying, there may be another state in between which is not valid, not invalid, something like that. We do not know it is tautology or we do not know it is fallacy. So in that case, we call the argument is not valid, but not invalid also. We are not sure. So we can say not valid, that's all. Okay. No, hold on please. Hello, Assalamu alaikum sir. जी अच्छा सर, जी सर, अच्छा, जी सर, जी, है, है, जी सर, স্যার, জি স্যার, স্যার তাহলে আমি আপনাকে পরে ফোন দিই স্যার, আমার যে ক্লাস চলতেছে এখন, তাহলে ওই হ্যাঁ স্যার একটু লম্বা টাইম লাগবে স্যার, তাহলে আমি পরে আপনাকে ফোন দিব স্যার। ওকে ওকে স্যার, জি জি, সালাম। Okay, so there is another state in between what we can call not valid. So in that case, actually, the thing is not a tautology and not a fallacy. So what is the thing I am talking about now? Which one will be tautology and fallacy? That thing let us discuss now a little. So the things are called premises and conclusion, right? So premises and conclusion, these are the two parts in the argument. So let us think that my premises will be x. Let us think that the premises will be x and the conclusion will be y. So if you think about x, x biconditional, okay, let me give a gap. is the expression to consider. So we will consider x biconditional y. X biconditional y will be our logical expression. So one part is the premises, that is my x, and one part is the premises conclusion, that sorry, premises is x and conclusion is y. So we will think about x by condition y, and if x by condition y is a tautology, then the argument is valid. If x by condition y is not tautology, not fallacy, then it is not valid for sure, but not invalid, that is also not sure. So this is one thing. Another thing is a fallacy. So we will be definitely sure that the argument is invalid. So it is not valid also and surely not valid. So sometimes you can think, okay, valid, not valid. These are the two things. Argument can be valid and argument can be not valid. So that will be our consideration. Okay, you can think like that. But from the expression, there will be three categories. One is the tautology category, one is the fallacy or not tautology category. So this is the thing. Now you can think what will be the x and y for this example. There is an example, so what will be my x and y in this? So in this, the premises part has some sentences. Every sentence is a proposition, and you will combine all the sentences together. So say today is Monday, this is one proposition. So you will give a name for this. This is today is Monday is one proposition. Let us give a name A. This is my first proposition A. And we go to the shopping mall on Monday or Friday. So what do you think? How you will write the proposition in logical expression? What you can write like this? Can you think?
XOR.
XOR? No, it is simple OR. You can use XOR also because Monday and Friday will never come together. So either Monday or Friday. So XOR is also acceptable, but it is not written either or, not written in the sentence. So you can think OR also. So my point is, how can you write the expression for this? Is it B? No. It is like shopping mall jawa, going to shopping mall. Going to shopping mall is your B. So you will think that B implies, no, sorry, A implies B. If it is Monday, then you go to the shopping mall. If it is Monday, then you go to the shopping mall. Or there is another thing, or. So what is or? Or means this, and Friday, say being Friday, say being Friday, today is Friday, this is our third expression, maybe this is C. So you will write, okay, A implies B or C implies B. That means if it is Monday, then I go to shopping mall, or if it is Friday, then I go to shopping mall. Is that clear? So if you use XOR in between, that is also okay. That will be also correct. But I will say only or. So this is the second sentence, sentence number 2. This is the sentence number 2. It is the sentence number 1. Is that okay? Do you understand what I am saying?
Yes, sir.
Now think about third sentence. What will be the third number, 3-number sentence? When we go to the mall, we eat pizza. That means going to mall is B. It is already there. Going to mall is B. And we eat pizza, you need another variable. We eat pizza, we need another variable for this. Say this is D. So what you will write for this? It is again implication.
Yes, sir. B implies D.
Exactly. So number 3 will be B implies D, because if we, it is like if we go to the mall, then we eat pizza. So B implies D. That is the number 3. Sentence number 3. Now think about sentence number 4. What will be the sentence number 4? After we eat pizza, we go back to home with pasta. So that is another thing with pasta. Okay. So go back to home. It is another variable, maybe E, and we take pasta. So that is another variable. It is maybe F. So after we eat pizza, that means if we eat pizza, that means D, right?
Yes,
D,
sir. Implies E and F.
right? D implies bracket E and F, because we do two things. We go back to home and we take pasta with us. So that is E and F. D implies E and F. And the fifth number sentence, number 5. Fifth number sentence is what? Number 5 sentence is, today we are at home with pasta. So today we are at home with pasta means what? E and F. That's it. So we are at home and we have pasta with us. That's all. This is number 5. No more new variable, because we are at home. That means E, and we have pasta with us. That means F. So E and F. That's all. So you make your X. Now you make your X. So how the X will be made? X will be the whole part of the premises, and it is like 1 and 2 and 3. Okay, all and 4 and 5. All the sentences and this one and this one and this one and this one and this one, like that. So it is actually what? It is actually A, and there is a bracket kind of thing, blah blah blah, number 2, and then another thing, then 3, and another one 4, and another one 5, like that. Okay, so this is your X. And what is your Y? This part is my Y. Y is one single sentence, that is today is Monday, that is A. So fine, it is my Y. Y is only single sentence, and it is A, one single variable. There is no and, no or, nothing. So fine, this is my X and this is my Y. So when you are done with your X and Y, then you try to prove what is your X by condition Y. So if you can show this, that X by condition Y is always correct, it is always true, that means it is always tautology. So you will say, yes, this argument is valid, this argument is valid. And if you see it is a fallacy, that means it is false. That means it is false, 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 false. Every time false. So you will say this is not valid, invalid argument, invalid, completely invalid argument. If it is not tautology, in that case also you can say the argument is not valid. That means not valid means we cannot depend on this. So this is the situation. Now, how you can show that X double implication Y is a tautology or fallacy or not tautology, not fallacy, what? So you can do this by truth table. You can do this by truth table, and you can also do this by algebraic laws. So there are some rules. Okay, there are some rules. We call this inference rules. So algebraic laws are included in inference rules. So we can prove our expression as a tautology or fallacy or nothing by using a truth table or by using some rules. So truth table is easy, but it is long. Say in this example, how many variables you have? You have A, B, C, D, E, F. So 6 variables. So if you have 6 variables in the argument, how many lines you need in the truth table? You tell me, somebody. You understand my question?
Sir, repeat the question, sir.
So 2 to the power 6.
That's 64.
64.
Exactly 2 to the power 6. Actually, you have 6 variables A, B, C, D, E, F. So in the truth table, you need 2 to the power 6 line. 2 to the power 6 line means 64 lines. So 64 lines you make in the truth table and then column by column. So it will be very big. Okay, but it is easy. So this is the truth table method. And another thing is inference rule or algebraic rule. Like, I mean, we have already some rules, that is idempotent law, commutative law, associative law, De Morgan's law. Okay, so something like that. XOR law, all these you already know. And we will also learn some new laws, new rules, so that you can prove it algebraic way, not by truth table. You can show this in algebraic logical way. It is small, but it is hard, it is complicated. So this is the inference rule. The process is hard, complicated, but it is small. Truth table is very easy, but it is big. So if you have a big argument, if you have 10, 12 or 15 variables, then it will be very, very hard to make the truth table because of the size. So this is the thing I want to tell you today. Okay, so we will talk about inference rules and how to handle the arguments in the next class.